Okay, on the back page, we start off with some verifying problems. And that first numerator, sine squared plus cosine squared, you should know that that's 1. So I have 1 over sine squared of theta is equal to cosecant of theta. We know that sine is the reciprocal of cosecant, so I can switch that to cosecant of squared of theta equals cosecant squared of theta. We now have the same thing on both sides, so we're finished with that problem. Number 2, we're going to have to FOIL there on the left side. So I would get 1 minus sine of theta plus sine of theta minus sine squared of theta equals cosine squared of theta. So there on that left side, the negative sine of theta, positive sine of theta will cancel each other out, leaving us with 1 minus sine squared of theta. Think about the fact that we have, as an identity, that sine squared of theta plus cosine squared of theta is equal to 1. You want to remember that? We're going to use that here on this problem because it says 1 minus sine squared. So I'm going to adjust this by subtracting sine squared from both sides. When I do that, it will read cosine squared equals 1 minus sine squared of theta. So I know that 1 minus sine squared is equal to cosine squared, so I can substitute that into the left side of this equation. Cosine squared of theta equals cosine squared of theta. I have verified that. Number 19. I'm going to write secant squared as 1 over cosine squared. Okay. And then we'll do the same thing with cosecant, except we get sine of theta times 1 over sine of theta. Those were reciprocals, so they equal 1 when you multiply them together. So over here I have sine squared times cosine squared. That's tangent squared. Plus over here, sine times the reciprocal of sine. Those cancel out. We just get 1. Equals secant squared. We have this as an identity. We have tangent squared plus 1 is equal to secant squared. So I can replace that left side with secant squared equals secant squared. Check. That one worked. Number 20. Look at this second denominator, 1 minus sine squared. Remember what we had up here? We just solved for 1 minus sine squared a little bit ago. It equals cosine squared. So I can replace that denominator with cosine squared. At that point, look at the two fractions. They have a common denominator. I just as well combine them into a single fraction. So my numerator will be cosecant squared of theta minus cotangent squared of theta. That's all over cosine squared of theta equals secant squared of theta. Now we have an identity that has both cosecant squared and cotangent squared in it. That identity is 1 plus cotangent squared of theta equals cosecant squared of theta. Let's think about that identity for a moment. If I wanted to solve this, I want cosecant squared minus cotangent squared, so I would subtract cotangent squared from both sides. So it would read 1 equals cosecant squared minus cotangent squared. Well, cosecant squared minus cotangent squared is what I've got. So I get 1 over cosine squared of theta. Well, 1 over cosine squared is secant squared of theta, which equals itself. So we verified that one. Now we move on to the equations problems. Number 21, I just need to divide both sides by 2. Cosine of x equals 1/2. Draw my triangles. Cosine is positive. Cosine is positive in the first quadrant. And then ASTC, it's also positive in the second quadrant. Or the fourth quadrant, I meant to say. So in both cases, my adjacent is here, it's just 1. Hypotenuse is 2. We know that's a 30, 60, 90 triangle. And the reference angle would be a 60-degree angle, which is pi over 3. So in the first quadrant, pi over 3 is an answer. It's not asking for general solutions, so I can say comma. Now my fourth quadrant one, I would have to take the full 2 pi minus a third. Pi 1 minus, or 2 minus 1/3 is 5/3. That's 5 pi over 3. So pi over 3 and 5 pi over 3 are my answers. Number 22, I need to add 4 and then divide by 3. Secant squared of x It's equal to 4/3. It's squared, so I'm going to square root it, and I have to do plus minus when that happens, which tells me it'll be all 4 quadrants. So that plus minus is important. Square root of 4 is 2. Square root of 3 is just square root of 3. I don't want a secant problem. I'd rather flip it. That would make it a cosine problem. So square root of 3 over 2. Let's make our triangles. Positive and negative, so I'm going to go all 4 quadrants. So got my bow ties. My adjacent sides are my square root of 3's, so positive over there, negative on the left side. Hypotenuses are 2's. So we've got all 4 angles. Reference angle, that's going to be a 30-degree angle. That's pi over 6. So my answers include pi over 6. And then in the first quadrant, you subtract pi over 6 from pi. That's 5 pi over 6. Anytime you're in the third quadrant, you're going to take pi and add the reference angle. So pi plus 1/6 is 7/6 pi. And then in that last quadrant, you take the full 2 pi minus your reference. So 2 pi minus pi over 6, that's 11 pi over 6. Move on to number 23. I'm going to add 2, divide by 2. Giving me sine of x equals 1. That's a quadrantal angle. Think about your unit circle. Sine is the y value. Where's the y value 1 on our unit circle? Only up here at 90 degrees, which is pi over 2. Number 24, we would add square root of 3. So tangent of x equals the square root of 3. You can think of that as over 1, so you have your opposite over your adjacent. Tangent's positive in the first quadrant. AST is also positive in the third quadrant. So always every 180 it's going to repeat itself. That's what happens in tangent. So my opposite, square root of 3, my adjacent's 1, or in this case, negative square root of 3 and negative 1. So reference angle there is a 60-degree angle, which is pi over 3. And then when I get to the third quadrant, we add a third of pi to pi. That's 4/3 pi. Moving on to number 25, I've got to add 1 divided by 2. 1/2, and then I have to square root plus minus, giving us that sine of x is equal to plus or minus square root of 1 is 1 and over square root of 2. That's going to be a 45, 45, 90 triangle. We've got all 4 of them, all 4 quadrants, because it's plus and minus. So opposites of 1, negative 1. Hypotenuses of square root of 2. Reference angle, which is really what I'm looking for, is 45 degrees, which is pi over 4. So in the first quadrant, that is pi over 4. In the second quadrant, it'd be a 1/4 shy of 1, so that's 3/4 pi. In the third quadrant, it's pi plus a 1/4, that's 5/4 pi. In the last quadrant, it's 2 pi minus a 1/4, that would be 7 pi over 4. Number 4, we're going to be able to factor out a cosine of x, leaving us with 4 cosine squared of x minus 3. So we have cosine of x equals 0. We get 4 cosine squared of x minus 3 equals 0. And that second one I've got to solve. Add 3 divided by 4, so 3/4. Then I've got a square root, along with plus or minus. So plus or minus square root of 3 over 2, as the square root of 4 is 2. So now let's draw triangles. The first one, got a quadrantal. Think about your unit circle. Cosine is the x value, so where is the x value 0? Well, the x value is 0 when you're on your y-axis. There's 2 points on the y-axis, so we're going to get pi over 2. I'm actually going to need more room here probably for these answers. I think there's going to be 6 answers on this problem. So pi over 2 is an answer. 3 pi over 2 is an answer. Okay, now let's go to that second picture. Here we're going to be able to draw triangles, all three quadrants, all four quadrants I mean, sorry. So square root of 3, negative square root of 3. For our adjacents, you can't even read that anyway. Hypotenuse is 2. So that's a 30-degree reference angle. So that's pi over 6. So pi over 6 is one of my answers. Then take away pi over 6 from 1 pi, so that's 5 pi over 6. I don't know if I'm going to be able to squeeze these in. I'm going to try. Go 1/6 pi after pi, that's 7 pi over 6. And then fourth quadrant, take 2 pi minus 1/6, that's going to be 11 pi over 6. So we get 6 answers there. Alright, now down to 27. I'm going to add 3 divided by 4. Square root plus minus the square root of 3 over 2. All four quadrants. Adjacents, the square root of 3. Oh, I even drew that. Sorry, opposite. Sorry, not adjacent. I drew the picture correctly. I just started to write wrong. Adjacent, opposite rather, is square root of 3. And negative square root of 3. Hypotenuses are 2's. Looks like we've got a 60-degree reference angle, which is pi over 3. So we've got pi over 3 in the first quadrant, 2 pi over 3 in the second quadrant, 4 pi over 3 in the third quadrant, and 5 pi over 3 in the fourth quadrant. And lastly, number 28. We've got a sine squared and a cosine. We have two different trig ratios going on here. I don't want that. Sine squared, I can switch because of my Pythagorean identity. Sine squared plus cosine squared is equal to 1. We know that to be true. If I solve that for sine squared, I see that sine squared of theta is equal to 1 minus cosine squared of theta. So I'm going to substitute in place of sine squared here. I will substitute 1 minus cosine squared. So 2 times 1 minus cosine squared. Looks like we're using an x rather than theta. We have to distribute that 2. 2 minus 2 cosine squared of x minus cosine of x minus 1 equals 0. Combine like terms. Negative 2 cosine squared of x minus cosine of x. Now I'm going to get a positive 1. I don't want my lead coefficient to be negative, so I'm going to switch all of my signs now. So 2 cosine squared of x plus the cosine of x minus 1 equals 0. So it's a factoring problem. I'm going to have a 2 cosine of x in one of my parentheses. The other I'm going to have cosine of x. Each parenthesis is going to end with a 1. Looks like our this one needs to be positive. The one that gets multiplied by 2 needs to be the positive one, and the inside one needs to be negative. So now I can set each of those equal to 0. So we get cosine of x equals 1/2. And we get cosine of x equals negative 1. If you don't write small, you're going to might have problems on this particular problem. All right. Cosine is positive. The first quadrant as well as the fourth quadrant. Adjacent's 1, hypotenuse is 2. That's a 60-degree reference angle. So in the first quadrant, that's pi over 3. The fourth quadrant, it's 2 pi minus pi over 3. So that's 5 pi over 3. Let's look at the second problem. We're going to have a quadrantal here, so draw your unit circle. Cosine is the x value. Think where the x value is negative 1. That opens over here at 180 degrees, which is pi. There are the answers to that one.